All right, welcome to our lesson on types of compounds. We're actually doing two lessons in this topic. The first lesson, we're going to focus on one type, and in the next topic, we're going to focus on the other type. So in this lesson, we're focusing on ionic compounds. Before we get into the details of ionic compounds, let's just quickly go through the differences between ionic compounds and molecular compounds. The biggest difference, and this is what we're going to focus on in a bit, is that ionic compounds are made up of metals and nonmetals. So they have both metals and nonmetals. They involve the loss and gain of electrons, which will be shown in a bit. They usually have high melting and high boiling points, and it dissolves in water. On the other hand, molecular compounds are only made up of nonmetals. Instead of losing or gaining electrons, they usually share electrons. They have relatively low melting and low boiling points, and they usually don't dissolve in water. The two main differences are the first two, so what they're made up of and the gain and loss of electrons, or the sharing of electrons, as is the case in molecular compounds. So those are the two differences. The other two are more properties that are observed in most ionic and most molecular compounds. Okay, so what I want you to do is from this list, identify all of the ones that are ionic compounds. So you're given a huge list here. I want you to pause the video, and then I want you to identify which ones are ionic, which ones are molecular, based off of the periodic table that I have here. So take in this periodic table, anything that is blue, all of those elements are going to be metals, and anything that is green is going to be nonmetals. Go through each of these and see if they have both metals and nonmetals. If they do have both metals and nonmetals, they're going to be ionic compounds. So pause the video, do that, and then come back. So the ones that are ionic, I'm going to identify that with an I. So NaCl, ionic. MgF2 is ionic. Al2S3 is ionic. CaO is ionic. And K3P is ionic as well. Okay, so please make sure that you're familiar with that, and don't worry if it's taking you a while to find the element on the periodic table. The more practice that you do, the more you work with your periodic table, the more familiar you will be where each of those elements are. So that means that all of the remaining elements are molecular compounds. All of the remaining compounds are molecular compounds. Okay. So let's move on. Before we do that, let's look at a trend that we saw to be true when we were learning about Lewis structures. So when we were learning about Lewis structures have the element symbol and valence electrons. So the only electrons that we're looking at were the electrons on the outermost shell. And there was a pattern that we talked about then. And that pattern was that anything in group 1 will have one valence electron. Anything in group 2 will have two valence electrons. We're going to jump over anything in the middle. So group 3 to group 12, we're not going to look at in this semester. Group 13 will have 3 valence electrons. Group 14 will have 4. Group 15 will have 5. Group 16 will have 6. Group 17 will have 7. And group 18 will have 8. So that is the pattern of valence electrons. So those are just the electrons that you see on the very outside of the outside shell of the element. So just to recap, for example, if we're looking at phosphorus, I would know automatically because it's in group 15 that phosphorus has 5 valence electrons. Now taking that a step further, there's another trend that I haven't quite talked about, but I want to draw your attention to it now. When we looked at ions that could form, so the gaining or losing of electrons, there are certain numbers that we assign. We assign it a charge, right? So after it gains electrons or after it loses electrons, we give it a charge, a plus or a minus, and then we give it a number. So there is a trend on the periodic table that shows you exactly what charge which element is going to have as an ion. So let's look at that. So if you've got group 1, if it's got one valence electron, what's always going to happen is that one valence electron will be lost. And if it's lost, it's going to have a charge of +1. So anything in this group, when it forms an ion, will have a charge of +1. Group 2 works similarly. Anything in this group, or any element in this group, if it has to lose electrons, it's going to lose all the 2 that it has on the outermost shell, which gives it a charge of +2. Same with group 3. If it's got 3 electrons, it's easier for it to lose those 3 than to gain any more. So anything in group 1 will have +1. Anything in group 2 will have +2. Any element in group 13 will have 3 valence electrons. It's going to lose those 3. Now group 14 is a bit of a weird one. If you've got 4 electrons on the outermost shell, you can go either way. You can either gain 4 to become a full shell of 8 electrons, or it's going to lose those 4 so that the shell right underneath it is going to be its outermost shell. So I'm going to write here +4 or -4. You can go by that. However, I'm going to admit right now that we're not going to see a lot of the group 14 elements, so you're rarely going to have to assign a charge of +4 or -4. If you do, either of those will work. Group 15, now this is where it gets a little bit weird. If an element has got 5 electrons on the outermost shell, and it needs to have a full shell of 8, it's easier for it to gain 3 electrons than to lose the 5. So we've got +1, +2, +3, plus or minus 4. And because it's easier for it to gain 3 electrons, the charge that's going to have is -3. And the trend keeps going. Anything in group 16 is going to gain 2 electrons. Group 17 is going to gain 1 electron. And the noble gases are all complete shells, so they're not going to need to gain or lose. So I'm just going to put a 0 over there. Helium is a bit of an exception, but we're not going to talk about that for now. So this trend is very useful for you to have, and please make sure that you note it down somewhere so that you can use it very readily when you're making ionic compounds. Okay, so let's take a look at an example of how ionic compounds are formed. Always easier when you're showing how ionic compounds are formed to use the Lewis structure. So if I have these elements that are given in my compound, I'm going to first list them out. So Mg, that's my first element. That is going to be magnesium. And I know, because there's no number right next to the magnesium, that there's only one of it. So I'm just going to draw 1 magnesium. Next element is Cl. And Cl is chlorine. And this number tells me that there's 2 of them. So I'm going to draw 2 chlorines here. And if you remember from our Lewis diagrams, you know that we're not done drawing our Lewis diagrams yet. We have to include our valence electrons. So because magnesium is in group 2, I know that it's going to have 2 valence electrons. I know that chlorine is in group 17, which tells me that it's going to have 7 valence electrons. And that's going to be the same for this chlorine as well. Okay, so I have a situation here where magnesium has to lose 2, and both of those chlorines have to gain 1 each. So you might be able to predict what's going to happen, but this is how ionic compounds work. So this magnesium has got to lose over here, and this chlorine is going to gain. So that chlorine is completely satisfied. Now this magnesium, or this electron of magnesium, has to be lost as well. This is going to be given to this particular chlorine. So what just happened here? I had this magnesium that had 2 valence electrons. It needed to be lost. One was given to this chlorine, one was given to this chlorine. So all of the elements involved are completely happy now. All of their outermost shells are full. So let me show you their ion forms now. So magnesium, it used to have 2 electrons, but I'm not going to draw those 2 because they're lost. So I'm going to draw it in its ion form. When I've lost 2 electrons, it has a charge of +2. All right, let's do chlorine at the moment. So I'm going to draw my Cl, and it had 7 electrons, it gained 1, so I'm going to draw all 8 electrons. Again, I want to show this as an ion, so I'm going to put square brackets around it, and because it gained the 1 electron, gaining something negative will make you more negative, -1. Now, if I wanted to show both of these chlorines, I can draw this another time, or I can just put a 2 beside it to show that there are 2 of these chlorines. So 1 of the magnesium, 2 of the chlorines. So if I were to ask you on an assessment to show me how ionic compounds are formed, I want you to show me this entire thing and be able to explain it. Okay, so now moving forward, let's name this compound. And when you're naming ionic compounds, you always want to keep the first element as is. You're not changing anything about it. So the first element is going to be magnesium, right? And that doesn't change. We're not changing anything about that. The second element is chlorine. When it comes to nonmetals, when they're forming ions, as it did right here, you always change the ending of it to IDE. So instead of it being chlorine, it's going to be chloride. So the name of this compound is magnesium chloride. Okay, let's do an example where you're given the name of a compound and you have to figure out the chemical formula. Now, this is where the charges are very important. The first thing that you have to do is draw out or write out the name, the element symbol of the first element. So aluminum is Al, so I'm going to write Al over here. I've got my second element, which is sulfur, which is over here. Now it's shown as sulfide, but remember in the previous example that we just did, the nonmetal always, the ending has to be changed to IDE. That's why we see it as sulfide. But we know that it is sulfur. Okay, now what we're going to be doing, I'm going to change the color one more time. Green. Now is where we go back to what we learned about the ions that each of these elements form. So aluminum, so all of these will be +1, all of these will be +2, all of these will be +3. This is +4 or -4, -3, -2, -1, 0. So aluminum, because it's in group 13, will have a charge of +3. So I'm just going to write that on the top right-hand corner of this. Sulfur is in group 16. It's going to have a charge of -2. Okay, so I've got my element symbols written out. I've written out the charges, +3 and -2. And now what's going to happen is that I'm going to crisscross. So I'm going to switch up these numbers. So let me choose a different color so it's easier for you to identify what I'm doing. So the number 3 that was here for the aluminum is going to go down over beside the sulfur. And the number 2 that's here is going to go down beside the aluminum. So when you're making the chemical formula, it's going to be Al2, right? Because we've taken the 2 from the sulfur, brought it down over here, and it's going to be S3. So that is it for you to figure out the chemical formula. Now, if you were to draw out the aluminum and the sulfur and you do the electron transfer like I've shown here, it is possible. So if you want to do that to gain a more deeper understanding of what's happening, feel free to do that. But this is the shortest way that you can figure out the chemical formula of a compound. Now, here's a bunch of practice for you to do. I want you to pause the video, try and do all of these yourself, and then come back, and then you can take it up with me. So let's take a look at this first example here. Magnesium, Mg. So they're asking me, they're giving me the chemical name, and I'm going to convert it into the chemical formula. So Mg and O. So I'm going to write out the symbols first. Mg is in group 2. That's going to have a charge of +2. Oxygen is in group 16. So that's going to have a charge of -2. I'm going to crisscross those numbers. They just happen to be 2 and 2. And it's going to give me Mg2O2. Now, this is a scenario that I wanted you to encounter while we're doing this practice. If you have the same number, just like we do in math, you would always simplify. So if you have these two numbers, instead of just leaving it as Mg2O2, what I can also do to express it, so it's the same thing, I can write MgO. So you always have to reduce if you've got two numbers. And that's only the case for ionic compounds. When we look at molecular compounds, we would just leave those numbers as is. For an ionic compound, always reduce to the lowest form. Let's do the next one. LiS. So lithium is in group 1. It's got a charge of +1. Sulfur is in group 16 as well. It's got a charge of -2. I'm going to crisscross these. And when you bring those numbers down, you leave out the positive and the negative. Okay, you don't write those in as well, you just leave it. And so your answer here is going to be Li, the 2 comes over here, Li2S. Okay, the next one that I'm looking at is potassium nitride. So potassium is right over here, and nitrogen is right over here. So potassium is in group 1, so it has a charge of +1. Nitrogen is in group 15, so it has a charge of -3. So if I switch up those numbers, it's going to be K3N. And in both this example and the previous example, I had numbers with 1 in them. When I crisscross them, you can write the 1 if you want, but it's more accurate if you don't, right? So we know that if you just leave an element as is without writing a number, that we're only talking about one of them. So it's safe for you to write it as Li2S and K3N. Okay, the next one, cesium bromide. As I mentioned earlier, the more practice you do with your periodic table, the easier it is going to be for you to identify where these elements are. So cesium is right here, +1, bromine is -1 because it's in group 17. I'm going to crisscross these, they're both 1, so I can just leave them as CSBr. Okay, hopefully that makes sense to you. Let's look at naming these chemical formulas that are already given to me. This is a little bit easier. So Na2S is sodium sulfide. AlF3 is aluminum fluoride. Ca3P2 is calcium phosphide. RBF is rubidium fluoride. Okay, so that is pretty much it for that lesson on naming and writing chemical formulas for ionic compounds.